class, I have given an introduction about this chapter, motion, and we have seen certain definitions related to this, that what is motion, what is reference point, what is origin, all these things we have seen in the last class. Okay, so defining a motion is, how can we define it? If the motion of an object changes with the time, if the location of an object, okay, if the location of an object changes with time, the object is said to be in motion. That is, if something is located over here, if there is a car which is located here, with respect to time, if it changes its position and it goes to some other position, okay, then we can say that there is some motion over here. Okay, also we have seen what is distance and what is displacement. This also I have explained in the last class. Okay, what is distance? That is the total sum of all the length of the path. Okay, whatever path we have taken, okay, if you just sum up all the lengths, okay, for example, you started from here, you have gone in different direction, so starting point considered is here, then you have gone here, here, this direction. So whatever the length of this path, all the path together, the total length is called to be what we call it as the distance. Whereas displacement is the shortest possible distance, okay, from the starting point to the end point. We don't see the path over there. Path, no need to see the path. Rather, we'll just see only the distance between the starting point to the end point. What is the shortest possible way of reaching there? Okay, consider there's an aeroplane. So this aeroplane is going from one place, it is going to another place. Now, if you go by road, then we can go the same place a car is starting. Then, depending on the road and the traffic, okay, we have to go in a zigzag fashion, okay, to reach the destination. But aeroplane, it will try to figure out what is the shortest way, because there is no traffic problem, there is no disturbance by buildings and or any other kind of landscapes. Okay, so it will try to figure out what is the shortest possible way of reaching the destination. Okay, so this is a very good example of displacement. And even a car also, even though it is going in some zigzag manner, okay, but ultimately it is reaching here. So we'll find out the shortest distance. The shortest distance will be the same as what the aeroplane has taken. Okay, so in this, what becomes important is the direction becomes important. In which direction we are going, because it is considered to be a straight line. Straight line we have, because the shortest distance is a straight line. Okay, only thing is we should know what is the direction. Okay, so that is why distance is considered to be a scalar quantity. Distance is considered to be a scalar quantity because there we don't care about the direction. We can go in any direction. Okay, so it is just a scalar quantity. That is 100 kilometers, 1000 kilometers. We don't say it is going in the north direction or south direction. We don't think about it. We just talk about the direction. Okay, whereas when you talk about the displacement, particular, because you know you're going in a straight line, you'll figure out a straight line which is reaching the destination, and that should be the shortest length. That should be the shortest length. Okay, so there we will say that it has taken north direction or northeast direction with respect to the starting point. Okay, or southwest direction, whatever it is. So I told you in the last class that what is a scalar quantity and what is a vector quantity. Scalar quantity is something which only talks about the magnitude. It is only about the magnitude, whereas vector quantity is both magnitude as well as direction. Magnitude and direction. Magnitude is what? Magnitude is the distance. Okay, or any particular value if we have an exact value of something, that is called as the magnitude. But the vector quantity includes the distance also as well as direction also. Okay, so it is having both the magnitude as well as the direction. Okay, now here you see what is displacement. There is a formula given for the displacement, that is given as delta x. Delta x is equal to xf minus x naught, xo. Okay, so xf is the final position and xo is the initial position. Okay, because o refers to the origin, o refers to the origin, and f refers to the final point or the end point. Okay, so delta x is what actually? Delta is actually change in displacement. Okay, change in its position. How much of displacement has happened over here? Okay, how much of distance has been covered? Change in position from one place to another place. Okay, that is only displacement, right? So if there is something which is moving from this point to this point, okay, so displacement has occurred over here. Displacement has occurred here. Okay, so this point, let us consider this is the final point xf. This is the initial point xo. X is the position of the object. Okay, so this displacement is given as delta x. It is given as delta x. Whenever we are using this delta, remember one thing, it is for a change, to show some change. So here what is that change? Change in position, that only is displacement. Okay, so that's how, if we subtract the final point to the initial point, we can find out the distance. Okay, for example, the final point is say 100 kilometer, and the starting point, the origin point was say 10 kilometer. Okay, that is our starting point. Not necessarily that always we are starting from zero. Okay, you can also start from zero if required. If you shift a reference point to the initial, that is to zero mark, okay, then it is zero. Otherwise it can be considered as 10, 20 or whatever it is. Okay, so now what will be this? 100 minus 10, that will give me the displacement. How much this vehicle has displaced? It has displaced 90 kilometers. If the starting point was zero, then the displacement will be 100 minus 0, that is 100 kilometers. Okay, now what is this zero displacement? Zero displacement means if we have this value, that is xf minus x naught is equal to 0, xo is equal to 0. If we get this is equal to 0, then we can say it is zero displacement. Okay, that means the starting point and the end point, if both are same, if the starting point and the end point are same, then both will cancel out, it will be 0. So that means there is no change in position. There is no change in position. Okay, so when the first and the last point of the object are same, the displacement is 0. Now here is a question, example of zero displacement. Okay, see, a person has started to move from here. He has gone to this point B, 3 meter, then he has gone to point C, from there D to A. Now this person has moved. Okay, he has 3 plus 5 plus 3 plus 5, that is 16 meter he has moved, but he came back to his original point, to the origin point. Now what is it? This is an example of zero displacement. Even though this person has moved, but ultimately he came back to the same point. So starting point and ending point are same, so in this case it will be zero displacement. Distance is okay, distance is understandable, distance will be 16 meter, but displacement is 0 meter. Okay, Now, what is negative displacement and what is positive displacement? So here they are given an example of negative displacement as well as positive displacement. Now, this is something, it depends on your reference point. If you imagine something that you're going in this direction, this is your origin point, and if you imagine that this direction is going to be a positive direction, that is, say that this is the east direction, you're going to the east. If you think that according to you, this is your positive side, okay, you are moving from this point, you're going in this direction, this is for you it is positive. But if you see there is a vehicle which is in the opposite direction, okay, so in this case what will happen? For you this is going in the opposite direction, so this is considered to be negative. This is considered to be negative. It depends on your reference. What is your reference? For you, the other person who's coming opposite to you is negative, and for that person you are negative, and he himself is positive. Okay, so that's what is shown over here. You see this point, from this point, if this is positive, then this is considered to be a negative direction. Okay, so here displacement of an object B is negative. Okay, and object B, where this object B is, it is at 12. You see this B is at 12, right? And he is coming to this point, that is 7. Between 6 and 8 means it is 7. So this is a negative displacement because the direction is opposite to your direction. Okay, and how much of negative displacement has occurred over here? So for this person, what is the starting point? For B, the starting point is 12. Sorry, the starting point, yeah, it is 12. So that is, I can say XO is equal to 12. Okay, and he's going in this direction, and the ending point is here. So this ending point is how much? It is 7. That is XF is equal to 7. Now formula cannot change because of change in direction. Formula will remain the same. That is XF minus X naught only. So here, what will come first? XF, that is 7 is coming first, and 12 is coming next. So 7 minus 12 is obviously going to be minus 5. Okay, so you see we are getting a negative sign here. So the negative sign also indicates that it is in the opposite direction. So it is a negative displacement. Okay. Next, scalar and vector quantity. Already I've explained to you what is scalar and what is vector quantity. Also, I've explained to you what is distance and displacement. That is also explained to you. Then we have what is uniform motion and what is non-uniform motion. So when an object travels equal distance in equal interval of time, the object is said to be to have a uniform motion. That is, if it is covering, for example, it is at this point and it's going somewhere. Okay, I'm tracing its movement at different interval of time. Say this is considered, this is after 5, say it is at 12 noon, at 12, and this is at 1. This is 1 p.m. This is 2 p.m. Same vehicle, they are not different vehicles. This is 3 p.m. Okay, so they are covering. I'm tracking its movement after 1 hour gap, and I'm also seeing that the distance it is covering here. If it is covering 50 kilometer, then here it becomes 100. Here it becomes 150. You see, equal distance is covered in equal interval of time. So this is an example of uniform motion. Non-uniform motion, if this doesn't happen, that now, for example, it is going for 1 hour, it is going at 50 speed, then second hour it is going at 70 speed, third hour it is falling to 40. So it is changing with respect to time. The distance is changing with respect to time. Then it is called to be non-uniform motion. Speed of an object is defined as the distance traveled by an object per unit time. Okay. Now talking about the formula for speed. Speed is given by, it's a very common formula. Speed is equal to distance traveled by time taken. That is, here it is given distance traveled by an object per unit time. Unit time means we are fixing a unit time like 1 hour or 1 minute, whatever. You are considering that as it as a unit of time. Okay. So for a fixed period of time, how much of distance it is covering, that is called as speed. Now, speed is equal to distance by time, we know. And what will be the unit for this is distance unit is taken as meter, SI unit of distance, and time take as second. So it becomes meter per second, m divided by s. Or you can also write ms power minus 1. Okay, because when you have something in the denominator, if you take it in the numerator, it becomes reciprocal, right? So that means if this s, now when it was, as long as it was in the denominator part, it was s power 1. It is s power 1. The same thing when you just take it to the numerator, this power 1 will become minus 1. Okay, that is why it is becoming meter per second inverse 1. ms power minus 1. Okay, that is ms inverse 1. Okay, should be written in exponent over here. Now the same formula in different ways they are writing. Okay, this is actually to show you the same formula, how it can be written in different ways. Distance, this already you know, speed equal to distance by time. Speed is equal to distance upon time. Now if you want to make it the formula for distance, so distance will be what? Distance will be equal to speed into time. So distance equal to speed into time. So what they have shown over here in orange color, that will be taken in one side, in the right hand side, and remaining thing comes to the left hand side. So s into t, the relation becomes d is equal to s into t. Okay. Now if you take t, okay, that is time. So speed equal to distance by time. So time, if it comes here, time is equal to distance, speed will go here. Speed, distance upon speed. Okay, so time is equal to distance upon speed. See, we have a line over here, okay, which separates the numerator and the denominator. Okay, so t is equal to d upon s. Okay, same way if you take speed formula, speed is equal to d upon t. Okay, next, what is average speed? So if the motion of an object is non-uniform, then we calculate the average speed to signify the rate of motion of an object. Now, if a vehicle is not going at the same speed, it is having different speed, 50, 60, 70, 40, 30, 20, something like that. So we find the average speed for that. Okay, if we have a fixed speed, uniform speed means 50, 50, 50, 50, it will be always be constant. So the speed also will be, the average speed also will be 50 only. Okay, but if the speed changes with respect to time, then we have to sum all the distance covered divided by total time, how much it has taken. Say it has taken 4 hours, so divided by 4. Okay, if the object travels 10 meter in 3 seconds and 12 meter in 7 seconds, what is the average speed for this? So one question based on average speed is given here. So total, see the distance, 10 meter in 3 seconds and 12 meter in 7. So 10 plus 12, that is the total distance. That's the formula, right? You've seen the formula for that. So total distance by total time. So total time is 7 plus 3. 7 plus 3. 3 plus 7. So that is 22 divided by 10. So it's going to be 2.2 meter per second. Okay, 2.2 meter per second. Okay, now next is velocity. Now there is, what is the difference between speed and velocity? When we talk about speed, it was distance by time, whereas velocity is equal to displacement. It is equal to displacement, that is delta x. That's how we represented it, right? Delta x by t. displacement by time. So from this one thing very clear, if speed is we have seen distance is a scalar quantity. Distance is a scalar quantity. Distance we have seen as scalar quantity. Scalar. Speed also will be scalar, because speed is from where we are deriving the speed formula, that is d by t, distance by time. So it's a scalar quantity. Whereas velocity is what? Velocity is displacement by time. Okay, that is change in position with respect to change in time. So here, because displacement is coming here, and displacement was a vector quantity, so velocity is also a vector quantity. Okay, displacement is coming here, right? This is displacement. What is displacement? Vector quantity. So velocity is also a vector quantity. Okay. And how we find the average velocity? Average velocity is nothing but initial velocity plus final velocity divided by 2. Okay. Initially, what was the velocity for that? Okay. Finally, how much of what velocity it is reaching? Add it. Both you have to add. Okay. Divided by 2, you will get the average velocity. Okay. That is in case of uniform motion. Okay. So in uniform motion, why this formula is coming is initial velocity will be 0, because when you starting a vehicle, when you start a vehicle, okay, it is starting from, it was at rest, and from rest it is coming to motion. So as long as it was at rest, it will be 0. Okay, so it is starting from a position of rest. So initial velocity is 0 plus final velocity. We have some, it is reaching some velocity later. Okay, so that both should be added and divided by 2. Okay, or it's, if it is not at 0 also, okay, it may not be even 0 at in what case it will not be 0 is already it is running, the vehicle is already running, but we started measuring its velocity, we started the reference when it has attained some certain velocity. Okay, after that only we started measuring it. So that time we'll not consider it as 0, rather we'll take at what point we have started to measure its velocity, from there we'll start. Okay, whereas average velocity formula for non-uniform motion, if it is a non-uniform motion, what will happen is total displacement. I told you what is displacement, right? So that displacement you have to measure and divide it by total time, so it will give you the average velocity for non-uniform motion. Okay, okay, so today we'll stop up to here. So far, if anybody have got any doubt, you can ask me. Remaining we'll see in the next class. Okay, then I'm ending the session today.